I am Virender Singh, M.Tech second year student of Dr. B.R. Ambedkar National Institute of Technology, Jalandhar. Today I am presenting one demo lecture on the thermodynamics and its application for the gate point of view. As an engineering student, we all know about the gate. The gate is the graduate aptitude test in engineering, and it is conducted by the old IITs, seven old IITs and IISc Bangalore under the Ministry of MHRD. And it is so important nowadays for engineering student that because almost all the PSUs, public sector undertaking, considering gate score for the shortlisting criteria for the recruitment process, and also some of the state-run organization like Punjab State Power Corporation Limited or Gujarat State Electricity or some others state-run bodies also considering gate score as their recruitment criteria. And gate is also important for those students who want to pursue in further education, higher education, like in M.Tech, ME or PhD. So all IITs, NITs and the government-run colleges considering gate score as their admission criteria. So, and some of the foreign universities like the University of Singapore and some of the universities in Germany also considering gate score for the admission process. So nowadays it is very important and essential for the engineering student to prepare for the gate. And gate is nothing, just gate will just check the fundamentals of the students about the various subjects in common subjects in engineering. And the preparation of gate requires time, dedication and time management, because time plays an important role in gate, because in 3 hours 180 minutes you have to type 65 questions among various subjects, and so time management is a very important key success factor for gate. So as for thermodynamics and its application, we know that the thermodynamics is a branch of physics that deals with the energy, heat transfer and its effect on the physical property of the substance and its application. And we, as a gate point of view, we find its application in the IC engines and refrigeration and air conditioning and various cycles like vapor cycles. And so what is the sometimes, and in the various cycles, these various cycles consist of the processes, and there are 5 to 6 processes. They are repeated in each and every cycle. So sometimes it is very difficult for the students to memorize which process belongs to which cycle. So what I have done, I have to remember these cycles with their processes with some short forms, and I learn this in the terms of some stories. So I will telling you one story of two friends to learn the various cycles and its processes. After 12th, two friends discussing about their future, their future course of study. So one friend suggests the other friends that you should prepare for a CAT exam. As we know, CAT is most common exam, common eligibility test. And second friend prepared for the CAT, but unfortunately he is not able to crack that exam and he fails in that exam. So he is very disappointed and talked to that friend again. Then that friend said that nowadays the government is giving more initiative to the Make in India program, and in Make in India there will be a lot of job in coming 4 to 5 years. So you should prepare for engineering entrance exam. So as we know earlier, the exam is known as the PET, pre-engineering test. Pre-engineering test. So the second friend prepared for the PET and he luckily clears that exam and he got admission in a good reputed college. But after going to the college, he deviated from the line, and he indulged into various other activities. So the first time he purchased a bike for which company? TVS company. As we know, the TVS two-wheeler manufacturing company. And also they started going to gym. And as we know, for muscle, for energy, we need some carbohydrates, protein. So he used to take ghee. And ghee of which company? Nova company. So he used to take ghee manufactured by a Nova company. And then he also started smoking. And but at the initial stage, as a college student, he don't have so much of money. So instead of smoking a cigarette, he used to take बीड़ी. तो एक बीड़ी पी ले. एक बीड़ी पी ले. And in the final year of his engineering course, his friend got a lot of supplies. So he's very disappointed, and the both friends again meet up, and the first friend again motivated him, and he suggests him to read autobiography of Dr. APJ Abdul Kalam. Dr. APJ Abdul Kalam autobiography. So he reads their biography and he gets motivated, and he clears his engineering exam and he got his success. So these are the various short forms of the common cycles in thermodynamics application. So from CAT you can have from CAT we have Carnot cycle. A for adiabatic. It consists of two adiabatic. And with T is a process, isothermal process. So two isothermal process. Next one is PET. And with E there is Ericsson cycle. With T same, two isothermal. And with P two constant pressure. Next one is the TVS. So in TVS there is no process with S, so it is a Stirling cycle as we know. And with V, two constant volume. Same T isothermal process, so two isothermal process. The next one is the Nova. With both we have motorcycle, and there is no process with N. So with V constant volume same, and with A adiabatic process. So two adiabatic process. The last one is APJ. With J we have one process, one cycle, Joule cycle. Same with P, two constant pressure, and with A, two adiabatic. So this is the way. So these are the short forms of various cycles consisting of various processes, and the one process is left with A, B, D, P. So with D, there is a diesel cycle, and it consists of one constant volume, one constant pressure, and two adiabatics. So these are the various short forms of various cycles consisting of various processes. In this way you can learn these things so that in exam you can recall these things very easily and quickly. So now I will explain one of the among these processes. Let's explain the Carnot cycle. So Carnot cycle is completely an imaginary cycle, but it is not practical to run an engine on a Carnot cycle. So it is given by the Carnot in 1824, and the use of Carnot cycle is that no other cycle will give the efficiency more than the efficiency that the Carnot cycle will give working between a same temperature limit. I am repeating, same temperature limit. Against this, if the one cycle and the Carnot cycle, if the both cycles are working between same temperature limit, so the Carnot cycle, reversible Carnot cycle, will give more efficiency than any other cycle. So as we know, the Carnot cycle consists of two adiabatic and two isothermal processes. So on a PV diagram, and the second graph is TS diagram. P for pressure, V for volume, E for temperature, and S for entropy. And as we know, the Carnot cycle is a two adiabatic process, and the negative slope of adiabatic on PV diagram. So first we will draw the isothermal. The slope of isothermal process is less than the adiabatic process. So there are two isothermal process, two slope, and the slope of adiabatic is more than the isothermal process. It is like that. So we start our cycle with the compression stroke. So here compression start from 1, we give it 1 point, 2 point, 3 point, and 4 point. Here in compression we are working on a cycle. So work is given to the system, and 2 to 3 heat is supplied at a constant temperature. So that it has heat supplied, and from 3 to 4 there is an expansion, and in expansion the work is given by the system. We will consider this work. And from 2 to 1 there is a heat rejection at constant temperature. So there is a heat rejection. So drawing same cycle on a TS diagram. Start from the compression adiabatic. As we know, the reversible adiabatic process is also called the isentropic process, and isentropic process the entropy remains to be constant. So it is a vertical line from 1 to 2. From 2 to 3 constant temperature process. So there will be a horizontal line from 2 to 3, and from 3 to 4 there is a work done, decrease in temperature, and from 4 to 1 there is a constant temperature heat rejection. These are the adiabatic process. Work is done on the system. Work is given by the system. The work is done on the system is negative, and work is given by the system is positive. So heat is supplied is considered to be positive, and heat is rejected from the system, it is considered to be negative. So these are the representation of the processes on a PV and TS diagram. So if we calculate the efficiency of a reversible Carnot cycle, the efficiency is nothing but the desirable quantity upon quantity that cost. The most generalized way of writing efficiency, and in books it is written as the desirable quantity is what? The work which we obtain from a so W net and quantity what the quantity at cost is the heat supply. So heat supply as we constitute this as a cycle. So as we see that it is clockwise cycle, so it is a work producing cycle, and for a cycle, due to first law of thermodynamics, we write first law of thermodynamics, the heat transfer change in internal property plus work done. So for a cycle, the change in property is zero because the initial and the final stage of the cycle is same. So the change in property is zero. So for a cycle, heat transfer is equals to the work transfer. So as we know, the area enclosed by the processes on the PV diagram gives you work, and the area enclosed by the processes on the TS diagram will give you heat transfer. So we can write that. What is W net? So W net is works from 3 to 4 minus work from 1 to 2. So by seeing the shape of the diagram, as you can see that it is quite easy to calculate the area of enclosed by this cycle instead of area enclosed by this, because it consists of a curvilinear area. So it is quite easy to calculate the area of this curve, area of this. It is a simple rectangular, and we know that the area of rectangle is length into breadth. So now we will calculate the efficiency. So with efficiency we can take that this minus this divided by this. So it is going to be temperature S. You can say S1, 2 is same. So S3, 4. S1 is equal to S2. It is a vertical line, and S3 is equal to S4. So we calculate this that S3 minus S1, this base, multiply by its height. Height is, we can given this temperature as a T higher temperature and this as a T lower temperature. So T higher, this minus this. This is same, base is same, S3 minus S1. This is T lower. However, heat supplied is same as S3 minus S1 into T higher. So as we see, the common thing from numerator and denominator is S1 minus S3 minus S1. It cancel out, and we are left with T higher minus T lower upon T higher. Or we can say that 1 minus T lower upon T higher. And in terms of heat supplied, it is also we can say that it is equals to 1 minus injected upon 2 supplied. Okay. So sometimes it is being asked how to, what is the best way to improve the efficiency of it, to increase the efficiency of a Carnot cycle. So by seeing this formula, 1 minus TL upon TH, if we decrease, if we decrease the lower temperature, and we increase the higher temperature, efficiency may increase. So there are two cases. So which one is best among these two? So in case 1, if we increase the higher temperature by some quantity, say delta. So putting this quantity into a formula, 1 minus T lower upon T higher plus delta. So it comes out to be T higher minus T lower plus delta upon T higher plus delta. So there is increase in a denominator, but there is also increase in a denominator. Let's take case 2. Case 2 is if we lower the lower temperature, if we moving to the entropy side by same amount delta. So what it comes out to be minus delta upon Th. So it comes out to be T higher minus T lower plus delta on Th. So in this case, numerator increased by same amount, but denominator is constant. So by seeing this case number 1 and case number 2, so it is I will decrease the lower temperature to increase the efficiency of a condenser. So the case 2, lowering this is a best way to increase the efficiency of a condenser. So this is all about the various processes in thermodynamics applications and how to learn these cycles against various processes with short forms and with a story, so that in exam you can recall it more quickly, because time is very much time plays an important role in GATE exam. So this is all about thank you.